Hello Cloud Gurus, and in this section I'm going to give you an introduction into Dynamo DB. I'm going to talk about what is Dynamo DB, what makes it special, and why it's worth using over other database systems. It will be a light introduction for those who haven't had any Dynamo DB exposure, and it will just lay the foundations for the lessons to come. So with that said, let's get started. So what is Dynamo DB? It's a fully managed NoSQL database product provided by AWS. And what training course would be complete without a sales-heavy sentence? So here goes. Dynamo DB provides predictable, fully managed performance with seamless scalability. Many database engines offer elements of this. Some are fully managed with questionable performance and scalability, and some offer scalability and performance, but require you to run the service yourself. Dynamo DB attempts to provide all three in a great value commercial package. You may read articles online referencing people who've had mixed experiences with Dynamo DB. And I'm going to say this at the offset. Most of these horror stories are due to people misunderstanding how Dynamo DB operates under the hood. While it is a managed service, you, as an eventual Dynamo DB user, have some part to play in its performance. If you fully understand how Dynamo DB functions at an expert level, you can achieve world-leading performance with little to no operational management overhead. And that's what I want this course to provide, the knowledge you need to make your implementation of Dynamo DB really excel. So let's talk about the specifics of Dynamo DB. What is it and what does it offer? Firstly, no visible servers. If I could have audibly added inverted commas around visible, I would. This will become clear in later lessons. In common with all technical services, there are servers somewhere, and knowledge of them will help you achieve the best performance from the product. But you don't need to worry about them at this level, so enjoy it while it lasts. Now you can almost ignore the volume of data which is being stored. There are a few situations you need to be aware of which can impact this limitless claim, but again, they are structure constraints that, if fully understood, won't impact your usage. Most people who start with Dynamo DB don't understand and eventually get hit by so-called limits. And these aren't actually limits. This is what I want to avoid with this course. I want to equip you in advance with knowledge of all of the product's gotchas. Dynamo DB is a fully resilient and highly available system. It's resilient to AZ failure, and data is replicated across multiple independent data centers. Data is accessed via a HTTPS endpoint. Hardware or DC failure will be transparent to your applications, and this is important to realize. Whatever the method you use to access Dynamo DB, even the console uses a set of APIs to access the database platform. Next, performance scales in a linear way rather than jumping around in a stepped manner as you would expect with other traditional database products. You specify how many reads and writes you want per second on a per table basis, and the system handles the rest. Now again, up until a point this is true for even the newest of Dynamo DB implementation engineers, as the database will work around bad data models and structures. With some knowledge, you can leverage the scalable nature of Dynamo DB and achieve bleeding edge transactional and throughput rates. If you read about scaling issues online, as I've mentioned above, it's generally a misunderstanding of good data modeling that's at fault. And in later lessons, I'll show you why and how to effectively manage data ingestion and ongoing operational performance in an effective way. Dynamo DB is fully integrated with AWS's IAM service. It allows controlled, granular access, including federated and web identity federation. This makes it perfect for mobile and web application usage. And don't worry, we'll look at how this works in depth in a later section. For now, understand that DynamoDB can be used at any scale and in both the traditional and web-facing architecture. DynamoDB is a NoSQL database engine, and by now you should be familiar with what that means. Additionally, and this is a fuzzy point at best, DynamoDB shares characteristics with key value and document store databases. And as you will see as I go deeper technically, DynamoDB draws on strengths and advantages from both product architectures. I've just scratched the surface, and as we progress through this course, you will gain understanding as to why DynamoDB is so effective. Let's move on to some more technical detail on how the product is structured. Let's start at the top. DynamoDB is a collection of tables in each region. As a region-resilient service, the service namespace is at the region level. Availability zones are unimportant in the DynamoDB architecture. Much like S3, you are paying for resilience within a region. Now, I will show you in later lessons how global resilience can be achieved, but for now, just know that basic region resilience comes out of the box with the product. Tables are the highest level data structure in the product. Your data is stored and structured in tables, and it's at the table level that performance is controlled and managed. Now, I'm going to talk extensively about performance in later lessons, but for now, know that DynamoDB uses the performance directives that you, as the administrator, provide, together with your data model, in order to provision underlying infrastructure that delivers on your performance requirements. Your request for X amount of performance is only half of the equation. And while up until a point that's all that's required, if you are planning to launch the next Netflix, it won't be enough. A key takeaway from this lesson is that up until a point, you can get away with simply setting a performance requirement and DynamoDB will deliver without issue. At a certain point, your design and data needs to be of a similar quality to the performance you're expecting, and that's where I and this course will help. One last structure point, and I've mentioned this in the fundamentals section earlier, but DynamoDB is a NoSQL database engine, and as such it has a fairly relaxed level of schema enforcement, and by fairly relaxed I mean almost none at all. You don't need to define your data structure in advance except your table keys. It can change over time, or it can be completely different for every item of your database. Now, as the old saying goes, with great power comes great responsibility, and it's your job as a DB administrator or operational technician to ensure you have an effective, high-performance data model, and this course will teach you what you need to know. I want to move on to table and data structures within DynamoDB, as I think it's useful that we understand that and some of the terminology that we'll use throughout the rest of this course. I mentioned on the last slide that the high-level data unit within DynamoDB was the table. A table, as with most non-relational and relational row-based databases, is divided into rows, but specific to DynamoDB, these rows are called items, and I want you to get used to instinctively referring to these as items. It will make discussions around DynamoDB or reading online articles around DynamoDB much easier to follow. And if, like me, you come from a historically non-DynamoDB system, this will feel wrong at first. So start referring to them as items now rather than rows. So moving on, each item contains one or more bits of data. And due to the relaxed schema model of DynamoDB, items don't have to contain the same data. Now, these elements are called attributes, and each item can contain the same or different attributes. There is little enforcement of structure on the table. So let's recap. In DynamoDB, there are tables. Tables can contain items, and items have one or more attributes, most of which can be different between items or can be uniform across the entire table. There are a number of special attributes though. Firstly, we have the partition key. Now let's get comfortable with this one. This is the unique key for the item, and it has to be present and it has to be unique. You may see the partition key referred to as the hash key. For now, just remember it has an alternative name. Later in the course, you'll understand why it used to be referred to as the hash key. The partition key is used within data operations that require specific item selection, and it's the primary table index. Optionally, a table can have a sort key. This is similar in function to a composite key used in relational databases. It allows multiple items to exist for each value of the partition key. A very common way sort keys are used is where time series data needs to be stored for a given thing, which is represented by a partition key value. The sort key used to be known as the ranged key or the range key, and both of the names give clues to its main function. Firstly, it orders items within the database or sorts items, and secondly, it can be used to efficiently ask DynamoDB for subsets or ranges of results for a given partition key, and more on this in an upcoming lesson. So, a table has items, items have attributes, items have the same or different attributes. All items need to have the partition key and the sort key if the table has one. Partition keys used to be called hash keys, and sort keys used to be called range keys. So far I've demonstrated what an attribute is in terms of item and table structure. Now let's look at what an attribute can contain. I've mentioned previously that Dynamo inherits a lot of its features from key value databases, but it also gains some from document style databases, and this slide will begin to illustrate why. Attributes are the smallest data unit within DynamoDB, and it's one of the very few places that Dynamo has any form of schema or data structure requirements. An attribute is defined with a certain data type when it's created. And keep in mind that an attribute type is specific to that attribute in that item. You can have two attributes in different items with the same name and different data types. Keep that in mind when you are working with DynamoDB. DynamoDB supports three main types of attribute data type families: scalar, document, and set. Let's look at each, starting with scalar. For those without a data modeling or programming background, a scalar data type is one which represents one value, and in that family we have string, which stores simple text. We have number, which stores simple numeric values. We have binary, a data type designed for storing simple binary data, and more on this later as there are better ways of storing large data blobs. And finally we have boolean, which can store simple 0-1 or true-false logic. Now next we have sets, which are used to store multiple scalar values. For example, we have string sets, which can store red, green, blue, or other combinations. We have number sets, which can store 1, 2, 3, or other numbers, and we have binary sets. Now, as the name suggests, each of these set types are used to store sets of their respective base scalar type. The takeaways for this are that sets are all of the same data type, and the order of the values in sets is not preserved. It's an unordered set of data. Finally, we have the document types, which is where DynamoDB inherits some of the capability from a document type database. The document data family has two data types. Firstly, we have lists, which is an ordered set of values. The order is preserved and is important. Think of this as an array if you have any software engineering experience. Also, a list can contain elements with different data types, as the one that's shown on your screen at the moment. So we've got strings and we've got numbers. Lastly, we have a map. Now, a map is an unordered data structure, and if you have any experience with JSON or lookup tables in software engineering or dictionaries, for example in Python, you'll know how a map works. You can provide a name and it will return the value. And you can have nested structures up to 32 levels deep, and those structures can be all of the above data types, including JSON objects themselves. Now don't worry about all the details, I'll spend a lot of time on this in an upcoming lesson. For now, just know that the functionality exists. Crucially though, and this is where the document DB feature set comes from, Dynamo DB allows you to perform operations based on elements in the map attribute, even ones which are deeply nested. Well, that's the end of what I wanted to cover in this basic introduction lesson, Cloud Gurus. If you need to rewatch it, that's perfectly fine. For people without database knowledge, it's worth doing, as I know there's a lot to take in. The concepts and terminology introduced in this lesson will be used continuously, so watch it as many times as you need to. Over the next few lessons, I'm going to introduce working with tables and items using the console and CLI, so you can follow along with your own environments or just watch along with me, whatever works the best. If you do have any questions about subjects covered in this lesson or any others, feel free to reach out directly or via the Cloud Guru forums. Otherwise, thanks for listening. Feel free to complete this lesson and move on to the next.